So navigation. Now remember, I have split the API into navigation, interrogation, manipulation, and synchronization. So this is the first big chunk of information. And I have separated navigation from clicking on things, because I'm going to count that as manipulation. So let's look at what the API does for us in terms of navigation. So at the driver level, we have a couple of fairly simple methods. We have the get method, which, given a URL, will navigate directly to a URL. We have a navigate chunk, where we can navigate in a more fluid and literal style. So we can navigate to a URL. We can navigate back or forward, or we can refresh the screen. That's pretty much it. I probably use get more than navigate to, although navigate to is more literate. It's just I do a dot, get is there, I use it. So it really depends on what style you're using. Doesn't really matter, because remember, you can refactor any method to any other. But navigation is a nice simple thing to start with, which is why we're chunking it down. It will also let you move around a page quite easily, and you can do some very simple checks with it. You're about to start seeing some sample code. You may see something slightly different between the slides and the actual code. So in the slides, you'll see me instantiate a Firefox driver as a web driver. You'll see me get using that particular driver variable. When you see the actual code, you may see me using a class method called get, which is static on a factory class that I've created. Now that's because on my particular machine, Firefox takes about 10 seconds to start. So what I've done is I've abstracted away the getting of a driver into another class, and it will maintain that driver so I can reuse it between sessions. I will, in a couple of lectures time, drop down into that WebDriver class so you can see that. But here, just be aware that the examples will probably have the Firefox driver being instantiated, but when you look in the code, I've abstracted it away. So here's an example test. So you can see here what we're doing with the navigation is in the app_before class, because app_before class, remember, runs once per class, I'm creating a driver. Then in the test itself, I use that driver that's been created and navigate to http compendiumdev.co.uk/selenium/search.php, which is one of my test pages. It's a search engine built on top of Bing, which always returns a guaranteed set of results so that when we're writing tests on it, we can always see them repeatable. And you can see in the after class, I quit the driver. Now I'm doing this so that I create the driver once per class, and I quit the driver at the end of the class execution. That means that if any of the tests fail, the driver will still quit. It means that I can add more tests into this particular class, and they will run using the same session. Now the reason I abstracted it away was to have the driver session run across multiple test classes and make the tests faster. So let me quickly show you what I mean by the difference in code. This is the example test in the slides, and you can see me creating the Firefox driver. Then if I jump over to IntelliJ, here's the test in the actual code base. So you can see here I have commented out the driver, new Firefox driver, and I'm using this factory class to get an instance of a WebDriver. And in the after class, I've removed the .quit because this static class does something, it uses some Java functionality. I was about to say it does something clever. It doesn't do something clever. What it does is it uses some standard Java functionality to create a JVM shutdown hook, so that when the tests stop, when the JVM stops, the driver stops down automatically. So that's the only difference. So I'm going to quickly jump into this factory class and show you what's going on. Now, for those of you that are new to Java, this might seem a bit confusing, but I'm going to go through this anyway, because you can come back to this, you can look in the code, and the more that you understand over the course, the more that you'll grow to understand this particular class. So, what's important at the moment is, in here, I have a couple of static methods. So we've got the static WebDriver, which will be returned on the various calls. and I've got statics for the driver name so that I can configure the driver name externally. Now the get method, what it does is it says if I have already instantiated a driver, then check to see if it's still alive by getting the window handle, and if it's still okay, then just return it. If it's dead, then quit to close everything down just in case, then start a new one. I can get with a given URL and say maximized, and it will do the same thing, and it's basically just a set of helpers. Now you can see that when we do create a new one, I create a shutdown hook, which, and again you don't have to understand this, just be aware that Java has a thing called a shutdown hook that when the JVM stops, that code will run. And all it does is call the quit method in this particular class. And the quit method is very simple. It says if we have a driver, then quit it. Now there's various extensions in here to let me use different types of browsers. So I can start up with IE, Opera, Firefox, Google Chrome. We're going to cover all this later. There's also the remote driver in there. In this case I've used Sauce Labs. Now we're going to cover all this later. I just want to give you a quick overview of this, that I very often use these kind of helper classes, these manager classes, these factory classes to return drivers to me. And some people do this by creating a particular test class that they extend. I tend to not do that. I'll do that if necessary, if as I write all the tests I see that they all extend a particular type of class. But for this particular set of examples I've tried to keep it simple, and I've tried to keep it in line with the semantics that you'd expect to see just using WebDriver directly. So that's a quick overview, and the reason I've done this is that Firefox takes a long time to start up on my particular machine, and when I'm running tests I run all the classes and I want to share the driver between them as much as possible. Time for you to do a little bit of work and experiment with the navigation commands. So your mission this time is to use the URLs below, and using the navigate to, forward, back and refresh. Whenever you use one of these commands, make sure assert on the title to check that the navigation actually worked. And the URLs you're going to use are http://compendiumdev.co.uk/Selenium, which is my main Selenium page. Then you will also use search.php, which is a search engine, and you'll notice that all of these pages have different titles. You will also use the basic HTML form.html, and you will see these pages later on in the course as well, because these are pages that we're going to use. So we want the basic webpage.html, which is a very, very simple page, and we want the refresh page. And what that does is shows a different title every time it's refreshed, to allow you to, when you've refreshed it, know that a refresh has taken place. So you'll expect to see the Firefox pop up, do your navigation, jump around the different URLs, the page you should refresh, and your asserts will all work. So join me in 15-20 minutes and we'll check your answers with mine and see how you get on. So let me just put that slide deck up again. So go off to these URLs, navigate to, forward, back, etc., and refresh, and check on the titles using whichever assertion mechanism you want. So now it's time for me to show you how I implemented those exercises. So the first thing I'm going to do is run these tests. And you can see that Firefox does take some time to start on my machine. So hopefully those were very similar results to what you managed to achieve. So let me quickly run through the actual test itself. So a few things I have done. I have pooled into the top of the class some fields. One of these fields holds the driver, and it's static because it's being created in an @BeforeClass method, which means that I will create one driver for all the tests running in this class. And the rest of it, you can see I have created fields that are final private string, which means they're basically constants that I am going to use in the tests themselves. So I have one for the HTTP protocol, one for the domain, then one for the root URL, combining all of these. There's different ways of doing this, but I've pulled it out to strings, and I'm using string concatenation down here to make things simple. So I have done a navigation with a get, which simply does a driver.get, root URL, adds on Selenium, then checks that the page title starts with Selenium Simplified. I've repeated a very similar test with navigate to. I've used a different page, so I do a navigate to using a string and check for the title. Now, Java has a URL class that makes it very easy to build up these URLs. You can see here when I'm doing it with a string, I have to combine the protocol and the domain and various other things into a string. Using the URL, I can add in the protocol itself and the domain and the page I want into a URL. It will build an object, it will check to see if the URL is correct, and if it is not, it will throw a malformed URL exception, and then I can use that URL directly in the navigate to. So navigate to doesn't just take a string, it also takes a URL. Then I check for the title. So for the forward and backwards, I have done it all within a single test, so that I navigate to a particular URL, the basic HTML form, then I navigate directly to the basic web page. I check the title on each one of these. Then I check that when I go back to the first page that we hit, and then when I go forward, I go back to the basic web page again. Then for the refresh page, now this was thrown in to be a little bit more challenging for some of you, but let me run through this test and explain it. So to navigate with the refresh, I just do a navigate to, same as we've done before, off to the refresh page. I'm expecting this to be the start of the page, so I check that the page starts with the refresh title constant. Then what I do is to get the start time, this is very simple string parsing. I get the title, then I replace the first occurrence of refresh title constant, which was refreshed page on, with a space, and that will leave me with just the number in the title. I then parse that to get a long, so I'm just putting a thread sleep of 2 seconds, and I'm doing that to allow for time to advance, so that the next time that I refresh the page, I get a different title. So in this case, I am synchronizing on time, so a thread sleep seems like a fairly valid thing to do. I'm not using it to synchronize on a page, I'm using it to synchronize on the actual time advancing, so I need to wait for 2 seconds. Then I do a refresh, then I check the title is still the same start, so I'm still on the same page. Then I do the same to get the number back, then I check that the number that we got the second time is larger than the number we got the first time. Then the after class doesn't do anything for me, but chances are for you, you've got a driver.quit in there. So I hope that clears up any issues that you had and that you managed to do it, because if you managed to do it, then you've really got the basic navigation commands down pat, and you're ready to move on to the next set. So a few points to note about navigation. Synchronization is really important throughout all our tests. So one of the things we have to ask ourselves is, does navigation require synchronization? Because essentially when you load a page, when you do a get, the WebDriver will block until the HTML of the page is loaded. But this does not mean that the page is ready, because JavaScript will not have necessarily taken place at that point. the execution of the JavaScript. So this does not mean that the page is ready for manipulation or for full interrogation. And sometimes it may not even be ready for full navigation. Because if you look at the refresh command that we had, if the JavaScript has not taken place extensively, then a refresh may not trigger the necessary conditions to effect any change in the actual page. In our instance, the refresh did trigger the correct results because the calculation of the title was done on the server. If the calculation of the title was changed in JavaScript and was done based on a cookie that was also set up by JavaScript, then an instant refresh may not have made any difference. So sometimes we do require synchronization on navigation, and synchronization can be hard. You saw in the test that I used a sleep for 2 seconds. That is a form of synchronization. It's a bad form of synchronization when you're actually using it to allow for JavaScript execution. We were using it to synchronize on time, which is what a thread sleep does, so that's fine. And clicking. Normally we navigate by clicking on links or buttons or submitting forms, so essentially I view that as navigation as a side effect. When you navigate by clicking on things, it certainly requires synchronization, and we're going to cover that later in manipulation. But when I build my page object models, I tend to pull out navigation from the actual manipulation. So I will have navigation classes that will help me navigate around the site. And I do distinguish between navigating directly, which is what the driver.get and driver.navigate_to do. They navigate directly to a page. And I distinguish that from navigating by clicking, which requires synchronization, which is how the user will typically navigate your application. And even then, I pull that out into a separate class for navigation. So navigation is something that requires a little bit of thought. You've seen the basics. This will stand you in good stead for most of your navigation problems, but it's nothing when we automate the web is ever as simple as it seems. So let's move on to interrogation. We've done navigation, we've done the basics of it. Interrogation is where we get information back from the page. And I'm going to consider 2 levels of interrogation. Interrogation at the driver, where we get the title and the URL and whatever else we can get at the root level from the driver itself. Then we want to be able to interrogate the DOM. And this is where we start doing web element based interrogation. And in order to interrogate the different web elements, we have to locate them first. So as part of our interrogation, we're going to learn how to use findElements to actually locate the things on the page within the DOM itself. So our driver level interrogation are where we can get the title, we can get the current URL, we can get the page source. It's pretty obvious what these things do. It's pretty obvious how you use them. You do driver.getTitle. Now page source itself, you have to not necessarily rely on that too much, because it may not be returning what you expect. It may not be exactly what you're seeing on the screen, and it may not be in the format you expect. So, the easiest way to learn this stuff, and always the easiest way to learn this stuff, is you've had a basic overview, you know that you've got driver.getTitle, get current URL, get page source. What I want you to do now is take a little bit of time, probably only take about 5 minutes, and create a test which goes off to www.compendiumdev.co.uk/selenium/basicwebpage.html. Assert that the title equals basic web page title. Assert that the current URL is what you actually put in, and check that the page source contains the string, a paragraph of text. So let me just show you that. So you're going to go off to www.compendiumdev.co.uk/selenium/basicwebpage.html. This is what you're going to see. You're going to see something with a title, basic web page, title, as it says there. You're going to see 2 paragraphs. So your job is to write a test, goes here and checks for this. Do the best you can, and when you come back, we'll go through the sample answer that I have created. Give it your best shot. 5 minutes, come back. And welcome back. So I hope that went okay. This is my test. This is one I wrote. I'm going to expand this and show you in more detail in just a second. So let me just run this first of all. If I do Control-Shift F10, then it will run this test. There we go. That was fast because all the test does is, given a URL, go to that page, navigate to that particular page, assert that the title is equal to what we're expecting, basic web page title. Assert that the current URL is equal to the URL we told it to navigate to. Then get the page source, then assert that it is true that the page source contains the text, a paragraph of text. And you can see I have also done a system.out println to show me the source code that was downloaded. Now, the source code that is downloaded is not exactly the same as the file that is on the server. So let me just show you. So this particular slide shows this is what I typed into a text file and have on the server. That's the formatting that is there. These are the IDs, classes. And this down here, and what you see over here in the output here, is what Firefox has returned. And you can see some subtle differences. The formatting has changed. I didn't have this XMLNS attribute in the HTML, but it's been added in by Firefox kindly for me. You can see the ordering of the attributes has changed from the way that I had it on the server. The class now is before the ID. I had the ID before the class. Now you'll also see differences between the different browsers. Here I'm only showing you what Firefox has returned. There are differences between different browsers in terms of making certain attribute names and tags uppercase or lowercase in the different browsers. So working with page source does not make your test very cross-browser. So if you do it, be very careful. I know that the browser difference will not change the actual text. If I put text on the page, it will not change on a browser-by-browser basis because it has to render exactly like that. So I can search for that kind of text in the source. But if I want to parse the HTML manually, which would be a strange thing to want to do, but I might want to do it, then I can't really rely on uppercase and lowercase. I can't rely on ordering. There's a whole bunch of various other things. So be careful working with get page source. So let's have a little bit more detailed look at this test so you can see the whole source. So you can see the imports that we've had to bring in. There's the normal, this is my driver manager. You'll have brought in WebDriver and possibly the Firefox driver directly. So if I change this to be how I suspect you've written it, WebDriver driver equals new Firefox driver. Then we go off to the page. Then you will have a driver.quit in there to close the browser session. I'd imagine that's pretty much what you've got. Let's see if that works. And it does. Now remember, we could have used assert that in our test. We want to assert that driver.getTitle is basic web page title. So let's import that from the We have a choice. We can use the is in the Hamcris core from JUnit or from core matchers. Let's pick that one. Because I did not put any message in here in the JUnits, so I'm assuming the test is very simple, but I did not add that. So now we're asserting that the driver.getTitle is page title. I can do this very similar thing here for the URL. Assert that the current URL is the test page URL. I could do this assert true page source. Now if I can't remember what the matcher is, I'm just going to jump off to JUnit source. So I'm going to do control left click on the is. Then in the JUnit section down here, I'm going to look for the matchers. Now you can see here I've got the Hamcrest matchers. I'm not looking for them, I'm looking for the one that comes with JUnit. I think it's the string contains. So there we go. Contains string is what I'm looking for. So if I do contains string, and then import that, and we want that from the JUnit matchers. There we go. Now if I run this test, in the test pass we've got the same result. Now you can see now that with the assert that, the test is much more readable. And also, if I was looking at this, I don't really need to system.out this, which would mean that I could move this in here, get rid of that. So now we have a much nicer, more readable and self-contained test that does a similar thing. So looking at this test, we can see that we instantiate a driver, we go to the URL, we navigate to that particular page, we assert that the title is the basic web page title, assert that the current URL is the URL we're expecting, and we assert that the page source contains the string a paragraph of text. Now, if you were doing it, I hope that you have moved these drivers out into the at before and after class, because if this test failed, we wouldn't quit the driver. So if I do this at, I'm going to put it in a before class, just in case I decide to add any more tests in here. You make it static because it's before class. Move this in here. Now, the reason I'm going through all this is to show you partly how to move these tests about, partly to show you that we can code on the fly, but also I just want to show you different ways of writing the tests. Oops, that's right. Public static void. Thank you. So now the test itself is becoming a little bit cleaner because all it does is what is important in the test. You can see now that what I'm doing with all this refactoring is I've got setup code moved out into a setup method. I'm going to take the tear down and move that into a tear down method. I'll call that stop driver. Because what is important, one of the things that's important to learn is that we want our tests to be as readable as possible. We want our tests to be as focused on the actual testing as we can. So not necessarily focused on the setup. The setup we want to push into at before and at after methods if possible. We want to abstract into some other method so that our test itself is readable. If I couldn't do all my conditions in a setup method, in an at before method, I may well move it into another method that describes the setup that I'm doing. But here I don't have to. Here the setup is really define the URL, navigate to the URL, and then check that the conditions that we're expecting in place are correct. So I better run this just to double check that we've done this correctly. So I'm going to do a Shift F10 again. Hopefully this will work. And there we go, the test ran and passed, and that one is a lot neater. So hopefully you've seen your example, you've seen the example that I created at the start, and then we've refactored it into this much nicer, much better one. And the reason it's better is that if the test fails at all, because after class runs regardless of whether the tests pass or fail, and because it runs after all the other tests have done, we will always close down the driver. There will be nothing left after this test is run. There you go. So now let's have a look at the DOM interrogation. The DOM is the Document Object Model. It's the browser page itself. It's the actual application that we're testing. So we have a number of things in here. Before we can interrogate the DOM, we have to locate the DOM elements. Everything that you see in an HTML page, like every paragraph, every heading 1, every heading 2, in WebDriver, that will be a web element. Now in the web element itself, we can interrogate it and use the following methods. So we can get text, which gets us the text in the element. So if it's a heading 1, we'll get the text that's in the heading 1. We can get an attribute. So if it's got a class, we can get the class. We can get the tag name, whether it's a paragraph, whether it's a heading 1, whatever it is. Whether it's enabled or selected or displayed. We can even get the size and the location and particular CSS values. All of these things we can interrogate easily directly from the web element. So I'm going to show you a canned example in this slide here. I'm going to look at the source code in a minute. I just want to pull out specific parts for this. So it's going to be, again, all these example tests are very, very simple. I've tried to distill everything down to its most basic to show you in context what we're going to do. So in this particular test, what we have to do is, given a particular page, which is the basic web page that you've seen before, we navigate to it, then we find an element by an ID para1. And then we assert that the text for that paragraph is a paragraph of text. This is much like you did before, but instead of getting the page source, we're going directly to the paragraph on the page and looking at the text for it. So let's look at that in context if it was an actual web application. So in the web application, I want to head off to http://www.compendium dev. Let's take an extra T out there. compendiumdev.co.uk Selenium basic web page. So this is what you saw before. Now the test is saying find the element by the ID para1. How do we do that? So if I inspect this, this is using standard Chrome functionality, by the way. I don't have any plugins in Chrome here that are helping me. But the kind of thing you're seeing me do here is the kind of thing we do when we're doing automation. What we have to do is we have to look at the page we're automating. We have to learn how to inspect it to see how to locate the element we want. So in the test, you can see I'm checking for a paragraph of text on the web element which has the ID para1. You can see here in the HTML, this paragraph has the ID para1 and the text is a paragraph of text. So that's what we're doing. And by using this inspect functionality, that's how I knew what I had to use in the test. So if I wanted to figure out how to locate this another paragraph of text, I do a right-click inspect element on it. In Chrome, it highlights this for me that I've just inspected. I can see it's a paragraph. I can see that it has an ID of para2, and the text is another paragraph of text. So the thing that is new here for you is the find element. We use the driver to find an element by a particular mechanism. In this case, I'm using the ID of the element. then I'm using one of the interrogation methods on the web element, because the findElement returns a web element. Then I close the driver. So let me quickly jump into the code and we'll have a quick exploration around this test, and then we'll move on to an examination of what these by methods are in the findElement. Web element interrogation test when you look in the source code. So this is the test we were just looking at. The only difference again being I'm using my helper factory class to get a driver. So you can see here we're going off to the basic web page. I navigate to it, then I do a findElement on the driver by ID. So this web element, you saw the interrogation methods that I'd listed out, the get text, get attribute, get tag name. If I do a code completion on this web element, you can see all the different methods that we can do on the web element. Get text is displayed. Get attribute, get CSS value, get location. These are all the interrogation methods that we can use. Get size, get tag name is enabled, is selected. Now there are some manipulation methods in here, click, but we're not going to cover that yet. What we're concerned about are the interrogation ones. And you can also see that from a web element, I can do a findElement or a findElements. So I can chain these findElements to navigate through the DOM. I don't have to build complicated XPath or CSS selectors. I can navigate through just by doing web elements. Now on the by method, if I have a look at this, at the moment I'm choosing to do a by ID. I could choose by name if there's a name, or a class, like the class name. I could choose text in the link or partial link text. Now most of these are pretty obvious as to how they're going to work. But if I get the Javadoc up for the by ID, you can see that by ID takes a string, which is the value of the ID attribute to search for. The reason I'm kind of labouring this, even though this stuff is fairly obvious, is I want you to understand a few things. I want you to get in the habit of reading the documentation that comes with Selenium. I'm doing a control Q on that method and I get to see what the documentation is. Remember, if I need to, I can control click through and see how this is actually implemented. It's a useful thing to do to get familiar with the code. I can code completion on the methods to see the scope of functionality that is available to me from that particular method. I can drop down into a web element, so I can see that a web element is actually an interface. So what is coming back is probably a Firefox web element, and I can see that it has a functional scope called a search context, which we can always use, which I think gives you the findElements. There we go. So a search context gives me the findElements and findElement functionality, which a web element implements for us, so we can chain them. And then I can look through and see all the other documentation for all the other methods that we've got. I want you to get in the habit of using either Chrome built-in inspect element. For Firefox, it has a, let me show you Firefox. Just going to copy and paste this URL for when Firefox comes up. There's Firefox in the background. So you can see Firefox has a basic inspect element. I don't think this is as good as the, if I do HTML mode, I don't think this is as good as the Chrome one, but that's why with Firefox I tend to use Firebug. Let me close this one down. Firebug is as good as the Chrome one. So if you're using Firefox, you install Firebug, then you get access to the inspect with Firebug, and there we can do much the same as we did in the Chrome browser. Opera has very similar functionality. Opera's is very, very good. So whichever browser you're using, you can do this inspect functionality, and this is really important for learning how to automate the pages. Let's run this and make sure it actually works. So we're going to navigate to basic webpage.html when the browser comes up. Then we find that element by the ID and we check the text. Remember again, you could assert that is if you want your asserts to be more literate, more readable, this is equivalent. And I expect you to be putting your startup code in an @before or an @before class method. I've contained everything down so it's a very, very small example, but this is not typically how you'd write it in the real world. Get used to using the @befores and @afters. Let me set that back to normal. Okay, so let's have a quick look at the scope of the find bys. So, we've got find by ID. That's the text that is contained in the ID attribute. XPath and CSS selector. We're going to cover XPath and CSS selectors later on, but they are the most flexible ways of finding elements on pages. All these other ones, by ID, class name, etc., would use those in the find element. If you want to do anything complicated, you'll chain them. So let's have some text that is contained in the text of a link, an href, an anchor, by name, which is the attribute name. Tag name is like the p(h1), and partial link text is a link that contains some string. If you experiment with these as we go through, then you'll get the hang for it. Without messing about, let's move on to an example of using the find by. Let me jump back to the code. Find by example. Here you can see it's an example test, but I've made sure I split out the before and after class. Again, I'm using the factory. You would use the Firefox driver, driver.quit built in, and the WebDriver outside is a static field, which means that our test is very, very simple. So this test basically says find by ID. All it does is return a web element from driver find by ID, which is a paragraph 3. We'll get the text. This is C paragraph text from this. So if we have a look at this page, this find by playground.php. This page looks pretty simple. It just says this is an A paragraph, B paragraph, this is nested paragraph text, then there's stuff with anchors in there. Now if we actually have a look at and inspect this, you can see that each of these paragraphs is within a div. Then we have the IDs and the names and the classes. So I can find by class name, I can find by name, I can find by ID. Then we have nested divs. So I could chain find bys if we want to. All of this stuff is open on this particular page. That's why I've designed this page for. It's designed for you to experiment with find bys and chaining. And you're going to use that now in the exercise, which I'm going to explain in just a minute. Okay, now it's time for you to get hands-on with the findElement and by methods to try some of these exercises. So go off to http://selenium/find_by_playground.php. Look in the DOM. You know how to inspect the DOM now. Do the inspect element. If you're using Firefox, remember to install Firebug. Then what you have to do is create a test for each of the following by methods. By ID, by link text, by name, by partial link text, by class name. Try some other ones if you want, but these are the only ones that we're going to care about at the moment because these are the easiest ones. These are the ones that, without really knowing much Java, without knowing much about WebDriver, you should be able to use these quite easily. Then once you have found an element, assert on the get text or the get attribute or one of the other web element level asserts and check that you found the right one. Now remember, if you use a find element with a by that would return multiple elements, e.g. find by class name P for a paragraph, you will receive the first element that matches. And if you get a no such element exception, that means that the locator didn't match anything in the DOM. So give it your best shot. Then when you come back in 20-25 minutes from now, I'll walk you through my sample answer and we'll explore this in a little bit more detail. And welcome back. So I hope that went okay for you. What I'm going to do now is run through the code that I wrote to meet those exercises. So you know the drill by now. First thing we do is run the test. Now this is not going to be the most visual text execution you're ever going to see, because all you're actually going to see is a browser start up, then everything is done in terms of the DOM. Everything is interrogation. There's no manipulation done. We get some values back into the test, we assert on them, and we're finished. You can hopefully see from your own test the value now of the @before and @after class. With more tests in your code base, the @before and @after really come into their own because you do all your setup at the start. Here I'm going to the page in the @before class. And because I'm there, every test now can just start working. And every test is now just focused on the actual assertion that it's trying to make. So I've done a couple of things that are extra from the exercise just to try and demonstrate things to you. So I'm demonstrating here that the no such element exception is thrown. You may have seen this when you were working through the test, when you were trying to find things and they were not there. But the way that we test for these things, you've got two options, and you can argue about this in your team as to which one is correct and which is not. I tend to try catch. Other people like to use the expected. Now the reason I tend to try catch is because when we're doing functional testing, we may have more than one method in it which can throw the exception that we're looking for. So as an example, we know that findElement throws a no such element exception. Now if I did the test like this, where I say @test expected no such element exception, what this is saying is, using JUnit annotation, I'm expecting when this test runs that a no such element exception is thrown. Now if I had more than one findElement statements in here, but I was only expecting the last one to throw a no such element exception, and I used this type of annotation, then if the first findElement failed for some reason, then the test would pass because a no such element exception is thrown, even though it was failing at the wrong point. That's why I tend to use the try catch syntax, because then I can have more setup methods, but the one that I actually want to assert is throwing the exception correctly, I will wrap in a try catch. Now you'll argue about this on your teams as to which one is correct. The devs are more likely to focus on this type of approach. And the reason they'll do that is that they are used to writing much smaller tests than we do. We tend to write tests that span areas of functionality, and as such, an exception can be thrown at points that we do not expect, and this can be a bit overkill in terms of what we do. So it looks like this is a bit onerous to write, but this is the approach that I tend to take most often. This test, when run, threw a no such element exception. Now you have to be careful when you bring in the no such element exception to import the correct one. So if I get rid of this, let me show you what I mean. So I now have two errors in the test because no such element exception is not there. Now if I do Alt-Enter to import it, you can see that I have a choice of importing from java.util no such element exception or Selenium. Now I want the Selenium one, otherwise my test will not pass. So now on to the exercises you were asked to do. This is all pretty simple in that I did an inspect, I identified an element, then I went and found it. And typically, so here I found paragraph 3 as an ID, and I asserted on the paragraph text. Now in the age, all the paragraphs have a unique text for the ones that have an ID. So you can see there's P3 with the text, this is paragraph text. So with the link text, I was looking for something with the link text jump to para 0. And then I'm asserting that the ID attribute on that link is A26. So let's have a quick look. If I scroll down to the links, jump to para 0, inspect that element, ID of A26. Find by name, I'm looking for a name of pname1. Let me just do a quick search for that. There it is. So it's one of the paragraph text at the top. And when I find that name, I'm asserting on the paragraph text. This is A paragraph text, which it is. The following one is this is B paragraph text. So that's a unique text, and I'm fairly sure that when that assert passes, the test has worked. So then you're asked to use the by partial link text. Now I have done this with 3 assertions to demonstrate that we can match the start of the name, or the start of the link text, the middle of the link text, and the end of the link text. If I do a find element for partial link text jump to, then that will match more than one item on the page. So find element will return the first one, which is jump to para 0. There's a number there that have jump to, jump to, jump to. If I was doing a find elements, I would get them all back in a list. Because I'm using find element, I get the first one back. Now the next one is saying find with a partial link text to. All the links have much the same text. So finding 2 will again match para 0. And I'm asserting again on the get text for that. Now when I search for 7, that will match at the end of the link text. Therefore, it will be jump to para 7. Now I do have a jump to para 17, so if I did a find elements on that, I would get number 7 and number 17. But because I'm using a find element, I get the first one, which is number 7. Then I did a find by class name, and I've chosen to search for special div. So let's have a look for that in the code. There we go. Name my div name, and that's what we've asserted on. I hope yours were as simple as that. If not, go back, try again. And if you want, feel free to experiment with some more. That whole page is designed to let you assert and find in many different ways. So you've seen findElement, which helps us locate a single web element, and the return value from findElement is a web element. We can write bys that match more than one element. You saw that when we matched on the link text. When we use findElement, we receive the first of those matches. If we want them all, then we use findElements. And findElements returns a list of all the elements that match that by class. So let me show you an example in the presentation slide. You can see here that I'm doing a driver findElements for a class named normal that will match quite a few elements in the page. They are all returned as a list, and they're stored in this variable, which I've declared as a list web element. Now in the test, I then go a little bit further to sort them out to find out exactly which elements have been found. So I've created a set, and I iterate around all the elements, and then I add the tag name into the set. And because it's a set, it will only store each tag once. Then I assert that I found a p tag, a ul, an li, an a, and that there is no div tag. Now you can run this and see it in more detail. The important things are findElements returns a list of web element. Because it's a list, we can use the normal Java functions to iterate around the list and to get the size. So let me show you this in the code. So here's the same test in the code. And remember, it's elements, so I can do things like get the size, I can check whether it's empty. If I really want to, I can add things in there. That may or may not be a useful thing to do, but that might be important under some circumstances, though I've never actually used that. So that's a brief overview of the findElements. It takes exactly the same by class that we saw before. The only difference between findElements and findElement is that findElements returns a list of web elements. So your task now is to use what you've just seen and use the Find By Playground page that you used before. And your job is to use a findElements with the appropriate by and assert that there are 19 div elements. So you're going to use a by to find all the div elements and then count the number returned in the list. You're going to do a similar thing for the anchors and check that there are 25 which have an href that links to a paragraph. If you're getting good at this, also assert that there are 16 nested paragraphs and 41 paragraphs in total. So the first two are designed for those people who are relatively new to Java. For those of you that already know Java, then push yourself a little bit further. If you can't do the bonus points, don't worry, I'm going to explain everything in the sample that follows, and then you can go back and do it. Remember, there's a whole bunch of things that you could do on that Find By Playground. I've just picked out these three to give you a chance to get used to findElements. Now I think this exercise will probably take 10 to 15 minutes, so give it your best shot, then come back and see how I solve the problem. And I'm hoping you didn't find that too hard, because I pretty much gave you most of the answers in the walkthrough and showed you different ways of doing that. Let me show you the test that I wrote. Let's just check first of all that they do run. Again, we won't see very much. The browser will start, it will do some interrogation on the DOM. The test will run fairly quickly once the browser is actually there. Great, all the tests passed. Now I did one extra thing that I didn't ask you to do. I did that because there is one subtlety with findElements that findElement does not have. findElement, when it cannot find the element, throws an exception. findElements does not. So here I've created a test saying, does findElements throw an exception if no match? And the answer is no. If I try and find elements with a tag name of Bob, there are none. So the element size on the list is 0. There was no exception thrown. This passed fine. So that's the only subtlety to be aware of when using findElement or findElements. Now that actually makes findElements very useful because no exception is thrown. Therefore we don't have to handle that. Therefore whatever we get back, we can iterate through the list. If there's nothing to process, there was nothing returned. Otherwise we can write the same code. So you were asked to assert that there were 19 divs. This is how I did it. I just checked for the tag name div, and there were 19. Now I'm going to quickly run ahead and kind of double check this, and I'm going to show you some XPath as we do this. So I have installed a plugin to Firefox into Firebug called FirePath, and I'm going to use that to double check the XPath. Because when you ran the findElements, you didn't see any results coming back. If I do it in here, I look for any element that has a div, then you can see that there are 19 matching divs, and they have all been picked out in here. And this is pretty much how I check my XPath and by statements before I use the FirePath or I use the search functionality in Firebug or Chrome or Opera, whichever one I'm using at the time. So that's the basic div test. Now you were also asked to check for local href links. This one might have been a little bit harder, but the reason it would be harder is that there are 50 anchor elements. But there are only 25 that have an href, because they're the ones that are linking to paragraphs. Now you saw that that was quite easy to do with XPath, but we haven't covered XPath yet. So in order to do that with the constraints that were imposed on us, I decided to check for the partial link text and just check for jump to para. Now to assert the number of paragraphs, let's have a look, because again this is a possibly tricky one in that you were asked to check that there were 16 nested paragraphs and 41 matching paragraphs. So there are 41 paragraph nodes. This is quite easy to do in XPath. I just say find me the paragraphs where the text contains nested, and there are 16. So I know that that's the correct answer that I'm looking for. Now the way that I did that was using very much the same construct that you saw in the sample test. I find all the elements with a tag name of p to find all the paragraphs. Then I loop through them all, and if the element, the paragraph element, if the text for that contains nested para, then I increment a variable called nested count, and at the end I go how many were in the list returned by the paragraph tag, 41, and how many did I count up as having the text nested para. So again, it's quite easy to use with XPath, but we haven't been taught XPath yet. But again, there's more than one way to do the same thing in any language. So I hope you were able to use your critical facilities and think through how to do it with the subset of by methods that you already know. And if you didn't manage to do it, look at the code that I've written, try it out for yourself, and remember, have an experiment and play around with that find by playground. There's a lot of stuff you can do in there. You might want to get ahead of the game by installing Firebug and Firepath and having a quick look at XPath CSS before we get onto it. So we've looked at findElement and we've looked at findElements. Now we're going to look at chaining findElement and one of the support classes, a byChained method. It demonstrates how to write custom by methods, and it helps us when we're chaining. And we're going to look at another support class for by ID or name. I haven't got any exercises around this, we're just going to run through and explain this, but feel free when we finish to experiment on the find by playground and put together your own so that you understand this. We can chain findElement commands. I'm showing that up here in a canned example where I have a findElement doing a by ID, which then chains to another findElement doing a by name. And we can use any by locator in any of the findElements that we're chaining. So in this example here you can see I've got a by ID followed by a findElement with a by name followed by a findElement with a by tag name. This allows us to run through the DOM hierarchy using whatever by method is most appropriate for the next level down. Now remember, we cannot chain findElements because it returns a list. Let me show you some source code that demonstrates this, and we'll have a quick look on Firefox at the same time. So in the example source code, when you look at it in the chaining find by example test, you'll see two examples of this. We've got the chaining with the findElement, where I'm doing exactly the code that you saw up there. So here I have driver.findElement by ID div1, findElement by name pname3, and findElement by tag name anchor. And what that does, if I look at this in here, I'm going to write some XPath as we go through here. So if I do a search, I'm going to do the equivalent of this findElement by ID in XPath. So I'm going to say find any element where the ID is div1. And the reason I'm using XPath is it's fairly simple to understand, but it's also relatively complicated and unusual the first time you see it. So I'm building up slowly to demonstrating XPath. I could do exactly the same thing in CSS, but I'm using XPath here because I think it makes more sense. I think it's a little bit clearer when we read it and compare it with the findElement. So the first thing I'm doing is a findElement by ID. Now that gives me the topmost div on the page. You can see here pretty much everything on the page has a dotted line around it because that's what is matched by this div1. If I open up the div1, you can see all the paragraphs and all the content in the page is underneath there. So really that's not narrowing down what I want enough. So if I follow it with another findElement, so I say starting from this element, find an element which has the name ename3. Now what we've done is we've zapped down a little bit further. So under div1 there's only one element that has pname3, and we've selected it here. So now if I actually want the anchor element, then say where the tag name is an anchor, and it's zoomed in on the particular control that we want. When you do not know XPath, or you don't know XPath particularly well, or you don't like XPath or CSS selectors for whatever reason, you can chain the findElement commands like this to make a very literal way of traversing through the DOM to get the web element that you actually want to work with. Now Selenium comes with a bunch of support classes. They're not part of the core Selenium, but they're in the jar that you download through Maven. You can use these to help you with your testing. ByChained is one of these. When we jump back to the source code, you'll see it. I'll show you where it is in the hierarchy, and we'll have a quick look at the ByChained source code itself. Now, ByChained extends by. It is building an object on top of the existing Selenium by method, which means we can use it anywhere that we can use a by method. It's a custom by method. So this is a really good example when you want to write your own by methods to make your tests read well. So what we basically do, you can see in the example here, I have to instantiate it because of the way that the class has been written. I have to instantiate it rather than use it statically. So I have to say driver.findElement new ByChained, and then ByChained takes as arguments a number of by methods. And what ByChained does is it executes each one of these by methods in sequence to return the element we're looking for. So this is pretty much equivalent to the last test. It's doing the same thing, but instead of writing 3 findElements that are chained together, I have got a single findElement where the by methods have been changed together. The by objects have been changed together. So let's have a quick look at that in action in the test. So there we go. This is it in action in a test class. So I have a driver.findElement, a new ByChained object, by ID div1, by name pname3, by tag name a. So one of the takeaways for ByChained is that ByChained is a custom by method, and if you look in the source code for ByChained, then you will get a feel how to implement your own by methods. I'm not going to go into detail at this point in time. Just be aware that ByChained is a support class. It's over here in org.open. It's over here in the Selenium support jar. There's a whole bunch of support classes. A lot of the things that make our life easier with Selenium come in these support classes, so it's worth looking through these to see what it comes with. Worth looking through these, not just because you're going to use them, but because they serve as examples as to how you can build on them and build on the core Selenium functionality to create methods and objects that make your tests more readable and more domain specific. So there's at least 2 reasons for looking through the support one. 1, you're going to use them. 2, you're going to use them as examples to build on as you get more familiar with Selenium to make your tests more readable, more reliable, and more easy to maintain in your domain. So that's 2 ways of chaining. We have the chaining findElement commands, or using the ByChained method. Now the other support class we're going to look at is a by ID or name. Again, this is another custom by method. So you can see in the example here, it will match on ID or name. So if I do a findElement by ID or name, put the string in there. If that string matches a name, we'll get it. If that string matches an ID, we'll get it. I've never needed this, but it's worth, again, being aware that it's a support class. If you do have the circumstance where the object you're looking for moves between an ID or a name, this may be absolutely perfect. But the other thing to look at for by ID or name is that it's another example of how to extend the by class. So if we jump down to the test that's using this, by ID or name, again I'm using the find by playground. This is a find ID or name match on the name. So pname2 will match the name. This will match the ID, but I'm using the same by ID or name to do it. Now if I jump into how this works, again you can see another example of a custom class, a custom by class. And it's worth having a look at this in conjunction with by chained to see how they're working their magic. It may be important for you to build on these. You can see that all by ID or name does is it first tries to do a by ID, and if that fails and throws an exception, it returns the result of doing the by name matching and if it can't find it, it lets the exception bubble up through. So you're essentially just doing a by ID, and if that matches, then you get the thing matched by the ID. If that doesn't match and throws an exception, then we do the by name. The findElements is a little bit more interesting because what it does is it finds everything that matches that ID, puts it into a list, and then does the same for the name, then returns everything. So when you do it with a findElement, you either get the thing that matches the ID first or the name. If you do it with a findElements, then you'll get everything that matches on the ID and everything that matches on the name. So you may find use for this. Great. What I do recommend you do is have a look through the code and learn how to use the custom by methods. Even if you don't use them, just bear in mind that it is possible to write custom by methods to help make your tests more readable for the domain that you're working in. Now let's learn about CSS selectors. In the olden days, when we worked with Selenium RC, I'm old enough to remember the olden days, I used a lot of XPath. So XPath is my default way of constructing locators. CSS selectors have much of the flexibility of XPath and the benefit that they tend to be faster. It's certainly in Internet Explorer, CSS selectors were orders of magnitude faster than XPath. I don't know what the correct values are now, but the general rule when writing locators, if you're not using by ID, by tag name, by whatever else, if you're using by CSS selector or by XPath, CSS selectors are generally faster. I am going to cover CSS selectors first. I would like them to be your default when writing locators for your by methods to identify elements on the page. I would like you to have an advantage over me where the CSS selectors are the first thing you think of. So CSS selector is what normal front-end developers use to match up the CSS styling with the elements on the page. We're doing the same thing. We want to use a selector to find elements on the page. A CSS selector is a pattern that matches a set of elements. Because it's a front-end technique, there's a lot of information on CSS selectors out there. I've listed a few here. Let's have a quick look through just to demonstrate that these things do work. SitePoint has a whole bunch of information on CSS3. And you can see here it's talking about universal selector, element selectors, class selectors, ID selectors. Now some of this I'm going to let you discover on your own, like pseudo classes, pseudo elements. Because it is possible, or it is more than possible, it's highly likely that we will overload you with information on CSS selectors in this section. And you will get away with a lot of the basics in most of your tests. You'll get away with searching for IDs or tags or things with classes. You may never need to use pseudo classes, but it's worth doing the research around this to learn them. Okay, so use some of these links as part of your learning. If you find any additional links that you say this is brilliant, everyone must be aware of this stuff, then please leave a comment in the Udemy course so that other people can benefit from your research. But this is something where I'm going to give you the basics. We're going to do some examples, but as you use it more, you need to do more research on it. There's a starter for 5 in terms of links that you can go off and have a look at. So let me just show you this in a test. Here we go. Here's my example test for CSS selectors. Now you have seen me in the past do by ID and then put the string in here for the ID. Oops, P3. That is equivalent to the CSS selector here, by CSS selector hash P3. Now why, if you've got something that says by ID and you can put in the P3 without all this horrible hash annotation, would you ever want to put in the CSS selector? And the reason is flexibility. The CSS selector is a formula, it's a matcher. If your element on the page changes, say it changes ID, say it changes position, say it moves under something else, it may suddenly not have an ID, but you can probably get to it through a CSS selector. So if you start using CSS selectors as your default rather than by ID or class name or by tag, when things move around the page, you'll find it much easier to keep your test up to date, because instead of going, I used to have an ID, now I have to search for it by tag name and change the by method that's in use, you can instead just change the CSS selector in the by CSS selector. You will increase your flexibility if you start using CSS selector or XPath instead of just the by ID, by tag name, whatever else. However, for maintenance purposes, it may be that the people coming after you are not as skilled as you are. So using by ID or by tag name or by class name makes your test more readable. This is a choice you have to make. I fully recommend you learn CSS selectors in more detail, you learn XPath in more detail, because the more flexibility you have in approaching how you get elements from the page, the better you will be at automating the applications that you encounter. So this is an example of using the ID CSS selector, and this is an example of how you select it by tag. So let's quickly run through the basics of CSS selectors. Now out of context, this won't mean anything. I'm setting you up here. We can use asterisks in a CSS selector to match any element. You saw the hash annotation to match an ID. So if I do hash ID in my CSS selector, it matches an ID. Dot class or dot something will match the class. So in the page that we're going to look at, dot normal would match the normal class. We can match tags just by putting them into our CSS selector. So P will match the P tags, A will match the anchor tags. And if we use square brackets, then we can match on the attribute names. So let's have a quick look at that in context. Now the way I'm going to show you is not by building tests for this. I'm going to show you in FirePath. FirePath, let's find it. I imagine you've already installed it. FirePath is an add-on for Firefox. And it lets us experiment with XPath expressions, CSS selectors, and jQuery selectors. And I have it installed here inside Firebug. What we just saw was we can use asterisks to match any element. And there we go, that's highly useful. I've typed in an asterisk as a CSS selector. This, by the way, is a drop down. I can choose XPath, CSS, Sizzle. So I've set it to XPath. I've selected absolutely everything in the document. Everything is selected because it matches that. That on its own doesn't give us much benefit. However, if I combine it with some of the other things, so we saw we can search for attribute. If I say anything with an attribute of an ID, it's matched anything that has an ID. Now the wildcard itself is fairly redundant most of the time. I can get away just by doing the ID. So that's matching for things that have an ID attribute. If I want to match something with a specific ID, and IDs are typically specific on a page, there. So I've searched for the P4 ID and it has matched it. Hash P4 is a P4 ID. I can be more specific and say I want a paragraph that has that has an ID of P4, and it will do the same thing because that's what you'd expect. Paragraph P5. Again, this tag name is probably redundant because an ID is supposed to be unique on a page. It may help make your tests clearer if you put it in. It's up to you. I mean, remember, you have flexibility when you're building these CSS selectors. You're using them not just to locate the element, but to communicate the intent of your test. Although it's redundant in this particular instance, with the P, it may be important for me to tell the next person that's coming to maintain my test that I am looking for a paragraph with this ID, or I'm looking for an attribute with this ID. There is none. Now it could be that if I just put in P5, it will continue to match. If someone changes the underlying application code, they may have moved the P5 onto an anchor or a div or whatever else. If I search for a P with a P5, I'm making my CSS selector very specific, and if the page underneath changes, then my test will fail. So you can get specific enough to actually make your test fail when the CSS selector fails. We can match the class name. You can see in here we've got class special div and class normal. The dot notation will match everything that has normal class or special div. And again, I can make this specific. I can say div, which is special div, P, which is special div, there is none. P, which is normal, there are. Are there any divs that are normal? No. So I can get very specific in terms of combining these with the tag name and the dot notation for the class value. Now remember, we can match tags. You saw that just on its own. Now one of the interesting things I should show you with the class name. You see at the bottom here I have a class that has multiple values in it. Now each one of these is a class value, so I can match it with .has or dot multiple. You can see that these class names are used throughout on multiple element types. findElements is often very useful with the CSS selector because you're going to get more returned. So matching the attribute name. I already saw an example of matching the ID. I can search for anything that has a class. I can search for only paragraphs that have a class associated with them. All these different combinations. Now let's look in more detail at the attribute matching. Again, this is just an overview to show you some of the possibilities that are open to us, and I'll go through the examples in more detail. You've already seen that we can match a tag with an attribute if I do P with an ID. Now we can look for specific values of attributes, so I can search for IDs of a specific type. We already know how to do that with a hash, but I could do it in here with this particular notation. We can combine attribute matches. So on this one, it must match specific tag where attribute 1 has a value attribute 1 and attribute 2 has a value 2. I can do an OR grouping over here with the comma value. So with no comma separation, it's acting as an AND. With the comma, it's acting as an OR. And we can do partial matches on the attribute value. The asterisk comes back for anywhere, so this will match an attribute which has the string ALU in the value anywhere in the string. The hat will match on the start of the value. These are normal regular expressions. The string will match the end. We can match for space separated values. You saw it with the .has using this annotation. So there's generally more than one way to do these matches. There's a lot of flexibility in the CSS selecting. So if I jump back to Firefox, we'll do some experiments with the attribute matching. So there's a div matching an attribute. If I put a value in here now and say I only want those that are normal, it has matched those that are normal. Now I can use double quotes in here if I really want to. Generally, if you're coding in Java, you'll probably want to use single quotes in your CSS selectors, because then you can double quote the entire string. Now I can search for divs that are class, divs that are class normal? There are none. But there's probably some that have got special div. Yes, there are. There's one in there. Now if I look for partial matches, and because this will match anywhere, I can cut this down and say I want you to give me a div where the class value has div in it, anywhere. And there's more now because we've also matched the nested divs. I've used div which is at the end, so I could tighten that up by saying only at the end we're getting the same values. If I change that to di, it hasn't matched anything now because di is not completely at the end, but it is in the middle, so that should bring those matches back. So you can see that asterisk matches the value anywhere in the value string. The string matches it only when it's at the end. I can match it at the start with the hat symbol. So we've got the SPE should match special. And I can do the same with any of these. Name, nothing. Where it has E in the name, there's fine, it's found 19. What about those that have M? So there's only 3 that have M anywhere in the name of the div. So let's have a quick look at the space separated annotation. A little tilde in there. I'm going to search for has, and there it goes. So that's the same as we did before with a dot has, but now we're being more specific. We're saying anywhere where a class, one of the values is has, and let's do the grouping. So if I do a div where the class matches nested div, great, we've got 16, and the name is nested div. This is probably the same. Yep. Remember, we can do the comma notation to say or. So if I say I want anything with a class nested div or name with M anywhere in it. Great, so now we've matched the first one as well. So that's a fairly brief overview of some of the main CSS selectors you're going to use. Asterisk, any element, hash for an ID, dot for a class name. You can match any tag, p, anchor, div, whatever else they've got. You can use the square brackets for attributes, and then within the attributes you can extend it to match on the value of those attributes as well. You know how to add it into a test by using the by.css selector. It's like any other by, it will go into a findElements, it will go into the chained, it will go into a findElement. Now tools for CSS and XPath. You've seen Firebug. I tend to use Firebug more often. Chrome is supposed to allow me to do searches on XPath or CSS. Most of the time it doesn't let me do XPath, or I'm doing it wrong. It does let me do CSS a lot of the time. So if I'm on the page here, if I do a Control F, then the find will come up. So I should be able to do a search for P4 as an ID. There it is, it has matched it, it just doesn't jump to it. ID P4. Now what's interesting here, you can see that when I inspect one of the elements, so I inspected this P8, let me make this bigger. So I inspected P8, which is this H paragraph up here. Inspect this H paragraph. You can also see that down here it has given me a CSS selector that matches that element. So it's a paragraph with an ID of P8 with a class of normal. You could, if you wanted, use that in your test. It's very, very specific. You could cut it down to p#p8 or cut it down to just #p8. It's your choice. That is very, very specific, and you can see that at the top level it's within a div with an ID of div1 with a class of special div. Now if I wanted to, I could do a findElement for this, dot findElement for the paragraph, and it would repeat pretty much exactly the same as what you're seeing here. So now it's time for you to do some exercises when we come back. So for the CSS exercise, go off to the Find By Playground, compendium-dev.co.uk/selenium/find_by_playground.php. Then create a test that is a findElement using the by ID for p31, and then create an assertion on get an attribute name and assert that it equals pname31. Create another test for by name ul name1. Then make sure the test has an assertion to check that the ID attribute is ul1. Create another test which does a findElement with a by class name for special div. And again assert that the ID is div1. Then lastly create a findElement test which does a by tag name on a list item, and then checks that the attribute name equals li name1. Then once you've got all those tests done using by ID, by name, by class name, by tag name, and they all work and pass, then change each of these by ID, by name, by class name, by tag name to by CSS selector, and write the appropriate CSS selector to make the test pass. That's relatively simple. These are fairly basic CSS selectors. Give it, say, 10 to 20 minutes. See how well you do, then come back and I will show you the answers that I wrote for this. Welcome back. I hope you had fun. In fact, of course you had fun. You were doing testing. You were doing test automation. What could be more fun than that? I have got two sets of sample answers. Because there are so many ways of fulfilling the result, I'm going to show you two ways I did this. The most basic way is doing it the way that I asked you to do it. So let's run these tests. I have a test for each of the things that we were asked to do. Find by ID, find by name, find by class, find by tag. So let me just run these tests and make sure they still pass. Again, we won't see very much. The page will open. We will do a lot of interrogation and the answers will come back and will turn green. Perfect. So we were asked to do the following. Create a test which finds the element by ID, then convert that into CSS. So I've done a by CSS selector #p31. That, remember, is how we access something by the ID, the hashtag. So to find name using CSS for the by name, to convert a by dot name into CSS, I'm doing an attribute match. So I'm saying anything with an attribute name which has the value ul name1. Then I assert on the ul1 that we're expecting. And we're tasked with doing a by class name special div and looking for the ID div1. So I convert that into a CSS selector with dot special div, because that's how we match a class name in CSS. Then finally we were asked to do it on a tag name, so taking a by tag name for a list item, and that's easy enough in the CSS selector land because it's just li for list item, then I take the web element and I assert on the value returned by getAttribute on the name. So hopefully you did something very, very similar, if not that. So let me show you the second example. Because as I went through this, I realized there were more ways of doing this than I wanted to write tests for. So I created a data-driven test. Now this is not a proper JUnit data-driven test. This is simply a test that loops around a set of data and checks it. So you can see here what I've done is I've created an inner class called testData, and I fill that up as part of this array sequence. So I'm basically saying my CSS selector is hash p31. I want to check that the attribute name is pname31, and this is equivalent. So this CSS selector is equivalent to doing by ID p31. I have a whole sequence of these, which we'll see in a minute. I just loop around that list. I do a findElement for the CSS item. Then I do a getAttribute for this value here and compare it against this one. And I'm using the assert that notation here to assert that element getAttribute for the one in the data structure is the value that I'm expecting from the data structure. So let me run this test, and then this will, because it systems out the list of CSS selectors, you can see the equivalents that I've used. So I just run that test. There we go, all tests have passed, and I have a nice output of what an ID I could use and what an equivalent is. We can step through this. For the by ID, where we put in the ID, we could have used hash p31, because that's the hashtag for the ID. Or I could do a CSS selector for an attribute ID with a particular value. And here I'm showing it with the two types of annotation, the single quote and the double quote, which I have to escape out when I put as part of a string. For the name one, I've got more options. I could do it on the basis of an attribute with the value. I could do it on the basis of any element with the attribute value. In fact, I could have done that up there with the asterisk as well if I'd wanted. I'm escaping out the strings here. I could have done it not just for any tag, but for the specific UL tag, because a UL that I'm looking for. And here I've done it with the double quotes. So here, for the class name special div, I've done it with a div.specialDiv, because I'm narrowing it down onto a div. Here I'm doing it with just the class name, and here I'm doing it with anything with the class name special div. And then for the tag name li, I've just basically done li. I couldn't think of any other options. So let me add that missing tests that came to mind as we went through there. So ID. So for the CSS, what I'm going to say is anything with the ID p31 is equivalent to by ID p31. So let's run that again, make sure that's correct. And that passed. So you can see I have all this different approaches for actually implementing it in CSS Selector. So if you didn't do all of those, why not go back, try and experiment some more. Either consider that good enough, or feel free to experiment more with the Find By Playground. Now to finish off with CSS selectors, I want to show you some of the, I guess you'd call them more advanced features, but they're not really, they're just more features. They're more Let's finish with some more features from CSS selectors. Now we're going to look at how to build paths from CSS selectors. It's one of the features that I like from XPath and I find very easy to use with XPath. And I struggle sometimes to remember what it is with CSS selectors, which is why I'm trying to present this here to you in an easy form. So if this is the first time you've seen this, hopefully you'll remember it more easily. Now the points here are, if I do a selector followed by a space followed by a greater than sign followed by another space followed by a selector, then it's basically saying match B directly under A. And I can do it as a descendant so that there's any degree of separation. A might be the great-great-great-grandfather of B, but because it's separated with a space, anywhere beneath A, if the B selector matches, then it will come back. I'm going to show you some examples of this in a minute. We can do search for children, either directly under or at any point in the family tree. And we can do searches for siblings, so where A plus B, where B is siblings of A. And we can also do B : first child, which matches the first child of B. Now you saw very briefly when I went onto the URL for the pseudo classes, there's a whole bunch of these different selectors to help you do paths, and I can encourage you to investigate this stuff. I typically, when I need to do anything like this, will just drop down to XPath because it's easier for me. I'm encouraging you, I'm trying desperately to encourage you to learn CSS to do this, because it will stand you in better stead and be faster. So let's look at some examples of this. I'm covering the basics simply because whenever you encounter a difficult to automate feature in an application, that's what should drive you to learn more CSS. That's what should drive you to learn more XPath. That's what should drive you to learn the innards of this, because you're finding a use for it. And that's the point at which you will remember it. So I'm going to show you some examples of this in tests, so you see it in context, and then we'll do some live on FirePath. So here are the tests. Basically, this is a direct descendant, so I'm looking for any paragraph that is directly underneath a div. And you can see here when I do a findElements on it, I'm expecting there to be 41 on the find by playground. Here I'm doing a list item directly under a div. And you'd expect that to be 0 because a list item is supposed to be directly under a UL or another top-level list construct. So let's have a quick look at those in FirePath. So off we go to FirePath, and we saw a div immediately followed by a paragraph. And you can see it's matched these paragraphs under this div. Now if I change that to a div which is immediately followed by an anchor, we get none. Div immediately followed by a paragraph, there's those ones. Now if I do an anchor beneath this, you can see it's matched all these anchors underneath these P's, underneath these divs. And if we look in the any descendant, so here you can see a div followed by a paragraph at any level of the hierarchy. Here you can see a list item at any point under a div has matched because it skipped the UL that's in place. So let's have a look at these. So we've looked at the direct descendant. If I take out this P and do a div followed by an anchor at any point in the hierarchy, we get pretty much the same result. That matched 50, that matches 25. So I'm getting more results when I say any anchor beneath a div. Now the example that was in the test, a list item anywhere under a div matches 25. If I say directly, it doesn't match because I have to put a UL in there to get a match. So that's those are what I use most often with CSS. I find those fairly simple to remember. Let's look at what else we have. Covered descendants. Now we look at siblings. So here I'm asking for a list item which has a list item as the sibling, and there's 24. There's actually 25 list items matching, so let's have a quick look at that. Search for list item 25. It's matched everything in that list, and if I say a list item proceeding with a list item, you can see that it hasn't matched the first one because the first item doesn't have one. It's the first child. So to get the first child, that's where first child comes in, and it's matched the first list item. So hopefully that gives you an idea of additional complexity that you can use with CSS selectors. And I encourage you to look through the references that we've given out, just so you have some understanding of the capabilities of the CSS selectors. You won't necessarily remember them, but you'll know that the capability may exist when you approach a problem and can then go and look it up. Now let's look at the joy that is XPath. Now XPath is much maligned because it's slower than CSS in terms of the browser implementation sometimes. I suspect the situation is changing, but XPath is generally slower. XPath has additional functions that CSS does not, so it may be more flexible. XPath can navigate up and down the DOM, so you can get to a certain point and then traverse back up to the parents. And XPath is often more verbose because it's an XML based language. Because I started with XPath, I find it more natural, but here's the advice. The advice is get in the habit of using CSS. Use CSS selectors for most of the things that you do. Then if you encounter anything complicated, start using XPath. Because if you're doing it complicated, chances are you're not doing it all the time. So if it slows down a little bit in your test for that really necessary part that you have to use it, then it's worthwhile. So the references I tend to use, I don't tend to use a lot of references for XPath. I tend to use the W3 Schools link. Now the thing to be wary of here is that this is describing XPath 2. The browsers tend to implement XPath 1, which has a subset of this functionality. If you want to see XPath 1, head off to the language spec and it will have the different functions that are available to you, because XPath has the ability to use functions. XPath also can check the content of the field. So CSS, you can't do any queries on the actual paragraph text, but you can do that with XPath. So I must remember to show you that. So those are my main references, the W3 Schools XPath tutorial and reference, and the XPath spec for XPath version 1. In your Selenium tests, you use it with the by XPath method. So it's much the same. Again, it's just a by method. It's just a method on the by class. So instead of by CSS selector, it's by XPath. XPath typically starts with // or it can start with /. That's the navigation. So let me just show you the XPath basics, then I'll show you these tests, then I'll show you it in Firebug. So with XPath, // means start matching this anywhere. XPath is essentially like a directory structure. So if I do /, I'm starting from the root of the document. So typically I'll have to do /HTML, /body, whatever else. If I do // I can match anywhere, so I can start doing // div. I'll show you this in a second. Like CSS, asterisk basically says match any element. Or I can do // then the tag name to match a particular named element. To do the attribute matching that we did in CSS, I use the square brackets again, and I prefix it with @ and then the attribute name. So @ for attribute. If I want to match on class, it's @class. And I can do the normal equals to match the attribute value. Now I can match the content in XPath with the dot notation. So I can say dot equals a particular value. I can traverse up and down the path. So in this example here, I'm doing // div /p /a to get me to an anchor. Then I'm doing dot, which will take me up to the parent, which will actually select the paragraph. I have all the different operators you'd expect. So let's have a quick look. So I've got equals, and, or, not, because XPath is a programming language. So we can do sums, multiplication, whatever else we want in there. It's enormously flexible. In some ways it's overly flexible. So having started learning it, I can use it for everything, but it's slower. So we need to learn both XPath and CSS. Plus CSS is cooler. And you're in with the cool kids, the front enders, when you start doing CSS selectors. And XPath has a bunch of functions for comparison. Let's have a quick look. So I can do comparison, I can check the start of strings. Now remember, XPath 1, not XPath 2, so you'd have to look in the spec to see what functions are available to you. So let's have a quick look through these tests I have created. So basically, this test, a certain number of paragraphs, is saying I want to find all the elements by the XPath /p. So it's basically saying, find me p tag anywhere in the document. This is saying find a specific paragraph. So /p with an attribute name, pname5. This is doing a path navigation. So this is basically saying, find me a div, then anywhere underneath that div, find me an anchor with this particular name. So let's do a quick run through of some of this in Firebug. We saw in CSS Selector land we can do things like div p, which will basically say, given a div anywhere, find a paragraph. In XPath, we do it like this. We say, anywhere in the document, find a p, then anywhere underneath that, find a. So anywhere in the document, find a div, then anywhere underneath that, find a paragraph. There we go. I can make it an absolute, so I'm saying I look for a div anywhere in the document where immediately underneath that is a paragraph. Then immediately underneath that is an anchor. Great. Then, what's good about XPath is I can say, actually I want the parent. So it jumps back up. So I've gone all the way down, I've matched the particular thing at the bottom, then I've got the parent. So let's have a quick look here in terms of content matching. So here I've got div p. There's a whole bunch of paragraphs and they have slightly different text. So I'm going to say, give me it where it contains, and I want to check the body of the paragraph, and contains b paragraph. So it's found one. So what I've done there is I've used one of the XPath functions called contains, and I'm matching the text of the paragraph, that this is b paragraph text here. Now I don't have to use the content of the paragraph when I'm matching. I could use an attribute. So I could say that paragraph has got a class. So let's say where the class contains norm. There we go, and that's matched all the paragraphs with class normal. So you can see there I'm using attribute inside a function. I can do this at this level. I can say give me a paragraph where the at class equals normal. Let's get rid of that bracket. There you go. So that's much the same as CSS selectors, but we can traverse through the path. We have functions. CSS selectors have pseudo classes. Learn them, learn the scope of what's available, then start using them. And the more you use them, the more you'll become familiar with either CSS selectors or XPath. And your XPath exercise is the same as what you did for the CSS. I want you to go off to the Find By playground, and again, create tests for the by ID, by name, by class name, by tag name, and convert those to use XPath instead of the by ID, by name, by class name, by tag name. You've already done this for CSS selectors. Simply a matter now of identifying the XPath that will let you do the same. I think this will probably take you about 5 minutes. So go enjoy yourself, come back and have a look at my answers. You want to see some sample answers, do you? Okay, well, I cheated. I copy and pasted the CSS test. What did you do? In fact, I used the data-driven one that I created, so I will show you that. Now remember, or you probably realized, or hope you did, I hope you explored and experimented with the different functions that were available, and I suppose you found some that were missing. We don't have ends with, we don't have matches, we don't have compare. So it really depends on your browser support for XPath. So again, you need to look at the spec, or you need to look at what your browser currently supports. And the reason I'm saying you may not get access is that I assume that the browsers will eventually improve their support for XPath and move on to XPath 2 and not just XPath 1. So let's look at the source code. So here's my data-driven test again. All I've done is change CSS to XPath and then put them in here. And I've changed my test so that I'm using by XPath to do the did. So let me run these. And we got the lovely all test passed message. So here you can see, instead of by ID for putting in the particular ID, I have done an XPath where I check for any tag which has an attribute of ID with the value that I'm looking for. And for the next one I've done the same, but instead of saying any tag, I'm saying give me a paragraph where the ID is P31. So instead of using the by.name, I'm using the XPath where I check for any tag name which has an attribute name. You can probably see the pattern here. Instead of doing an ID, I look for the attribute ID. Instead of doing the name, I look for the attribute name. Instead of doing the class name, I look for the attribute class. So in some ways XPath is, I find, simpler. It makes sense to me. So I'm also checking for a note that I'm basically saying anywhere in the DOM, just start anywhere in the DOM and look for something that has this attribute name. Anywhere in the DOM, I don't care where you find it, a UL element that has a name of UL name 1. And here I've used a function. I decided since XPath 1 doesn't have the function compare, doesn't have the string comparison functions, what I've done is I've basically gone, get me any element where the attribute name starts with the value that I'm looking for, and the actual length of the value in the name is 7. So that's basically a very long-winded way of writing a function that says this value equals the one that I'm looking for. I just wanted to do something that had a function in there so you can see how they work. So for the class name, basically saying any element where the attribute class is the value that I'm looking for, and then I've been a bit more specialized and said anywhere there's a div that has the class name special div. And for the tag name, it's easy, it's just find me anywhere a element that is an li. So hopefully yours was much the same or very similar, and that wasn't too hard. We're going to have another challenge in just a minute, but well done on that, or have a look at the code if you didn't quite get it. I just want to draw your attention off to one additional resource that you might find useful. It's the XPath CSS Selenium Rosetta Stone, and it's on this incredibly long URL here, so I've given you a shortened form here, the bit.ly rdj3w lowercase b. Let me show you what this is. So this is an article by Michael Sorens, and he has taken the time to summarize the differences between, or not even differences, the similarities between the XPath and the CSS and the DOM. These are PDF files, and what you can see here is if I want to select the entire web page in XPath, I do /HTML. In CSS, I just put HTML. Now the way you read this, because this is written for Selenium 1, and in Selenium 1 we had to prefix our XPath statements with XPath equals and our CSS statements with CSS equals. We don't do that in WebDriver. We use by.xpath and then just put in the actual XPath statement, by.css selector, and put in the actual CSS selector. So here, there's a whole range of these recipes in here, and you can see the XPath equivalent with the CSS equivalent. You can see that some of these in XPath do not have a CSS equivalent. So you can start to see where the power of XPath starts coming in. This is a very useful reference. And then there's another version of the file, but arranged slightly differently. So this is clearly a very popular post. It's a very useful reference for when you're starting with it and when you're trying to get a feel for the differences between CSS or XPath. Highly recommend that. And that is the full URL there, or bit.ly rdj3w lowercase b. Now we're moving on to frames in Windows. Frames is not something that I encounter a lot in production applications, however you might, so it's worth being aware of them. Particularly iframes get used now, kind of hidden iframes. Windows, pop-up windows, again, you might not encounter this stuff a lot, but it is always important to know the capabilities of what WebDriver and Selenium can give you. So this is the overview of the Frames API. You can see again that we change context, so we driver.switch to a frame in order to use it, and we can access the frames through the frame name, through the number of the frame, 0, 1, 2, 3, 4, 5. We can access it based on finding it as a web element. We can switch to the default content, which will take us back to the top of the main page. And when you switch your commands, you act on the new body in the frame. Now in the next lecture, we're going to drop down into the page and the code and the test to see this in action. I just want to provide a quick overview first. So in context of a test, you can see here I'm going to compendiumdev.co.uk/selenium/frames. That's the main test page that we've got set up for this. I assert the title. Then we switch to a frame called menu. So I find an element within that menu and click on it, and that will take me to a new page, and then the whole setup starts again. So the only thing that's really different here for frames is the switch to, then our findElement commands after we've switched it work on the body of the frame. That's an important concept. Let me just show you in a browser the example. So here is the frames page that we're using. If I have a quick look at the source code, so that if you haven't seen frames before, you get a feel for what they are. So you can see here that I have a frame set because everything is handled by a frame set in here. And I have multiple frames. I've got the top nav, HTML frame. I've got the frame set below, which has 3 frames in it, then another frame on the bottom for the footer. Now each one of these frames is an HTML page. So if I was to go off to frames footer.html, we can see that just as the page itself. However, in context, in HTML, a frame is an included HTML page that is displayed as a frame on that page. So all of these are using frames. If I click onto this iframes example, we'll be taken to a new page. And if we look at the code for this, you see that we have a different type of frame. We have an iframe. We have an inline frame in here, which again, much the same thing, it's just a slightly different HTML style. But you access it using the same mechanisms as you did before in the normal frame. And here is the example test as an actual test. So I'm going to show you this running. again, you won't see very much, you'll just see the page come up. But once we've run it, I'm going to put it in debug mode, and we're going to do a little bit of exploration around that page in the context of Java and the API. So now you know that this test works, and what this test does, remember, is basically clicks on a link in the menu, and the menu itself is an HTML page in a frame. And when we do that, it opens up a new page. So I am going to put a breakpoint on here. So just after we've switched to the new frame, and then we're going to have a look at how this works. So I'm going to debug this. Right, so now we're in debug mode. This is the page. WebDriver is still in control of this particular browser here. And what we've done in WebDriver is we've got to the point where we've just switched to the frame menu. So let's see which one that is. I think it's this one. Let me have a quick look. So that's frame menu, which is this one on the side. And what we're trying to do is click on frames example 1 HTML. But what is important at the moment is looking at what we've actually got. So if I evaluate driver just now, I'm just going to show a few things in the console. So we know that we have now switched to the frame. And previously I said that all your commands now act on the body of that frame. That's not strictly true. So if I do a driver.get page source, and oops, don't need that. Let's see what we get coming through in the console. Console's saying there's something to say. Let's have a look. So in the console, the page source that we've got back is for HTML frames example menu 1. And there's the body, and this is what our commands, or most of our commands clearly, are going to work on, but not the driver.get page source. Page source is giving us the frame. If I get the driver.get title, let's see what we get back. So title is for frame set example title, not HTML frames example menu 1. It's for the main page. So at a driver level, we haven't completely switched context over to the frame, just in case that's a little bit confusing. I said that the driver commands work on the body. So let's just double check that. If I do a find element, I'm going to say by tag name. Now remember when we did the exercise to recreate the get title command? So I'm doing a driver.findElement by tag name title. Let's see what we get back. Oops, well, clearly I don't want to just get the element, I want the get text of that element. So there we go. The text of the element returned by title is frame set example title, which is the main page, not the frame. So again, although we've switched context, and although we've said that the commands now work on the body, they don't all work on the body. So what we're dealing with is a kind of merging of the old header, the old main page header, and the body that's come in. So although Firebug, when we inspect it in Firefox, has shown us that there's more code in there, that's not what we're accessing. That's not actually what we see in the DOM, because you can't have multiple heads in the DOM. So what we've got is the body text that's been put in there. So it starts to make sense when what you're seeing is the difference between what you're inspecting and observing and what is coming back through the driver interface, through the web page itself. What we've actually got is a set of merged pages. Now let's just double check that we can access elements on the the body. So if I do a findElements by tag name anchor, that will return a list. If I do the size of that, let's see what we get. So we have 7. And if we look in the source code for this, in the body we have 1, 2, 3, 4, 5, 6, 7 anchor tags. So we have switched into the body of that frame, but the head stuff is still coming from the main page. I hope that isn't confusing, but it's an important distinction to understand that what you're seeing when you do Firebug isn't always what you're getting back through WebDriver. And so when I say when you switch, your commands act on the new body, most of the commands do. Some of them are still working with the old head. You can get at the head if you do the page source, then you'll see the whole thing. So that's the model of the page that you have to have in your head when you deal with frames. So I don't think these frames exercises are going to be particularly hard for you, but it's important to go through the exercise so you get this in your head. Now what we're asking you to do is a scenario test, 2 scenario tests, where you click on some things, navigate through and check the presence. So the first one is going to be clicking on content, load the green page, then on the green page, go back to the original page and assert for the presence of H1 content. So let me just run through that for you to show you what I'm expecting you to do. So I'm expecting you on the main page from Selenium/frames. So in the content, click on load the green page, which is this link here. So you'll have to Firebug that to see what it is. Then on the green page in here, click on back to the original page and then assert for the presence of H1 content. So you're clicking on links within the frame itself will change, and those are the assertions you're going to have to do. So the next exercise is going to require you to click on the menu and click on the iframes example. Then in the iframe, click on example 5. And then in the content, load the main frames page. And I want you to do a bunch of asserts as you go through that. So how did you do? Well, I only wrote 2 tests for each one of those scenarios. They seemed fairly simple. I'm just going to run my tests, then I'm going to explain them to you. So all my tests passed. Now let's have a look. Now the first thing we were asked to do was dealing with the green page. So click on content, load the green page, then on the green page go back to the original page and then check for the H1 content again. So this is how I've done it. So I start by asserting untitled to make sure I'm on the right page. Then I can switch to the frame with the name content. In that I find the element which has the link to the green page. Then I wait, and I wait for the DOM to change so that the heading 1 with ID green is present, which tells me that the frame has loaded correctly. Then I want to click on the back to the original page, and then again I'm checking for that frame being loaded by looking for the H1, because the H1 is changing each time I do this. Then I simply assert that the H1 does have the content. Now I don't really need to do that. I could get rid of that line. So we're going to do a refactoring exercise after this, so I'm going to quickly refactor these tests once I go through. But this was the initial attempt at solving these. So hopefully your test is something similar. Now for the next one, working with the iframe, I again check, am I on the correct page? Same here, am I on the correct page? Then I want to click on the menu frame, because that's where the iframe link is. So I switch to the menu frame, I click on the iframe link, and again I wait. But this time I'm waiting for the title to change because it's a page load. Then I switch to frame 0, because that's what the iframe is. There was no name, there was no locator on that particular page that made it easy, so I just used frame, the index on the frame. Then when I'm in the iframe, I want to click on the example 5 link. Then I wait again for the title to change, because this is a new page load that happens. Then I go back to the content frame, click on the index page, and check that my title has changed to be the title that we started with. So hopefully you did something similar. If not, have a look through the code, change yours, experiment with it a little bit. Now, one thing I didn't fully cover before is what happens if. And with the frame tests, it's basically a question of what happens if I do not switch? What happens if I do something, the frame changes, but I do not switch to that change? Well, all that happens is you get a no such element exception when you try to look for something within the frame. I don't think there's any other FAQs around frames that I could think of. Now, when we come back, we're going to have a look at refactoring this frames exercise to make it a little bit better. So let's do a little bit of refactoring. And there is an optional exercise ongoing throughout this where you can revisit any of the code that you've done and refactor it and make it better with what you've learned. The same with the sample code for this course. Look through it, refactor it and make it better. Experiment with it. Because one of the things that we do in the real world with automation is we constantly refactor. We constantly make our code more reusable. We constantly make it more maintainable. So we have already learned a few things that will make this code better. Now you can see I already have an answer in the code base here for frames exercise refactored test. But I'm going to do it as we go through here on the fly. So the first thing I'm going to do is just copy this class to allow me to refactor it. Normally I wouldn't do that, I would just refactor in place, but I'm trying to keep the code base stable. So frames exercise refactored. I'm going to call this refactored delete because I'm going to delete it straight away. You can do it within the frames exercise test itself. So looking through this, what can we see? Well, all of these expected conditions, presence of element locator, these can be brought in statically. So I don't need this class at the front. I can make this more readable. So instead of wait, new WebDriver wait until expected conditions, presence of element located, I can just say until presence of element located. So instead of bringing it in as a normal import, I'm going to create a static import. So the difference is at the top here in the import, I now have an import for expected conditions, and I have a static import for expected conditions, presence of element located, and that's what I'm using here to make the code more readable. So now that I've done that, I can use that in there. So this wait became a little bit more readable by doing that. Not massively. So let's make this wait more readable. Now you can see here that I'm creating a new WebDriver wait throughout the test. Again, I don't have to. Remember, this new WebDriver wait actually returns an object. I'm going to call that object wait. So that up here, before I run each test, I'm going to say the wait is going to be this new WebDriver wait. I'm going to make that a field. So I now have a private WebDriver wait at the field level, at the class level. Before I run each test, I create a new WebDriver wait for that, which I can then use in my test code as wait. Now in combination with the static import, you can see that the fairly clumsy wait clause we had now becomes wait until presence of element located by, which is a lot more readable. So let me do the same thing down here. So I'm going to wait until, and I want to say just wait until the title is. So let's statically import that, which becomes a lot more readable. Okay, so a lot of the time, oh, we've got one more, let's fix this. So sometimes refactoring is looking through the code and going, what is ugly? Let's make it better. Now you can see, as we go through, that we haven't yet used the hamcrest matchers in here. So I'm still saying assert equals some text driver.getTitle. What we really want is assert that the title is this text. So let me import the assert that. Let me import the is. And you can see again, those are static imports, which is what makes them readable in here. And we can do the same down here. I can do another assert that to remove that assert equals. And when I do that, I'm kind of reversing the arguments at this point. Assert that the text from this element is what I'm expecting. Do the same thing here. Assert that the title is what we're expecting. Now, in the other lecture I mentioned here, I'm waiting until this element is located. And I'm doing it by an XPath. Now really I don't need this assert at all. And the reason I don't need that assert is that this XPath is looking for an H1 where the text of that element is content. So this assert that comes after is really redundant. So I could get rid of that completely, because if it's not there, this will time out and throw an exception. Other thing I can do, when we look at presence of element located, you can see that it actually returns a web element. It returns the element it has located. So I could do a smaller refactoring like this. I'm going to call this element H1. So what happens now is, wait until presence of element located. If it finds it, it will return it as the web element. So in here, I don't have to look for it again. I can say, assert that h1.getText is content. Now we already know it's content because of the XPath here, but if we didn't, then this is a little bit nicer. I just want to show you that sometimes these expected conditions don't just return Boolean, they return the actual element we're looking for itself. So let's have a look through here. There's always more we could do. The point is, how far do we want to go? Now one hint, and we will probably cover this later in the course, is all these driver statements inside the test is a bit nasty, because it means that we're actually in the test saying, I'm going to click on this, I'm going to do this thing, I'm going to do the next thing. We're not making the test very expressive. And that's why I have comments in here. So I'm saying, load the green page. And to do that, you do these things. Now why, in the test, don't I just say, load the green page? Click on back to original page. I could do. That's where page objects start coming in. And the refactoring that will lead to that is the notion of, I don't want any comments, or let's try and not use driver directly in our tests. So later on you might want to come back to these tests and start refactoring them to remove driver. But that's enough for the moment. So the refactorings we did there with the hamcrest, creating a weight at the top to make our weights more literate down the bottom, statically importing the expected conditions methods to make this a little bit more readable. There's more to come, but it's always useful to revisit our work and refactor it. Always. And I'm sure some of you are about to point that out to me, but we haven't run the test yet. How do we know that all these changes that we've just made haven't impacted it? Compile time errors, we haven't got any, but we may have some runtime, so we better run this and make sure we haven't messed it up. Okay, we got a green light, all our tests passed, the refactoring worked. And having looked at frames, it's now time to turn our attention to windows, which have a superficially similar API to start with. So a window has a unique handle. Every single window that WebDriver is managing has a unique GUID when we're dealing with it. And the way that we get those handles is at the driver level. So if I issue a driver.getWindow handle, I will get the handle for the current window. And if I do driver.getWindow handles, I will return a set of strings of all the window handles that are currently available to me. And if I do driver.switch2.window, because again we're changing the context again, and put the handle in that I've retrieved from getWindowHandle or getWindowHandles, then I can switch between the different windows. Let me quickly show you on Firefox itself. Here's the frames page that you're used to. Within content, I have some links that open a new window. This one opens a new window on EvilTester.com. This one opens a new window on Compendium Developments. Both of these things can be switched to within the context of a test. So given this simple part of the API, let's look at an example that uses it, and then you will do an exercise that uses just these parts of the API. So the window example I'll show you in code in a minute, but this one is annotated to draw your attention to certain parts. So we go to the Selenium frames page. When I issue getWindowHandles with only one window, I will retrieve a set that only has one handle in it. I'll get the same handle if I do driver.getWindowHandle, and it comes back as a string, remember, because it's that long GUID statement. I can switch to the content frame so that I can then click on the link that you saw. It's the Selenium simplified link this time, which will also open up in a new window. And then when I check driver.getWindowHandles, the size on that, there will be two, because there will be two browser windows open. There's two tabs there. This is what is counting as a window. And remember, different browsers handle these different windows in different ways. Most browsers are tabbed now, so most of them will open it in tabs. And you can see in the test, once I've opened a new window, I can get to the window handles, and I can iterate through that set, same way as normal, and I can switch to different windows. And then any new driver commands will go into that window. Given that information, just the information about, from a driver level, we can get the current window handle, we can get all the window handles, and they come back in a set of strings, and I can switch to a window using a window handle that I have retrieved from getWindowHandles or getWindowHandle. That is enough information for you now to start experimenting with windows, and in the next lecture we're going to have a look at the window exercises, the basic window exercises. So our window exercise uses the frames page that you've seen before. And what I want you to do is start with the example that you've just seen. You can either take that from the source code repository, or I have added it as a file on Udemy for you to copy and paste into your IDE. You may have to change the package structure if you do that. But amend the example to switch back to the frame window and demonstrate that you switch control. So the example will click through into the new window. Your job is to switch back to the frame window. Then, two of the links on the content frame can be switched to by name, as well as by handle, EvilTester.com and Compendium Developments. Open both of those, and then switch between all three windows, two of them using switch to name, and one of them using switch to handle, and then close each window when you're done with it. So you have all the information that you need in order to do this. I haven't explicitly spelled it out, but if you try and do this, when we come back we'll have a look at the answers that I have created. So I'm going to start by running my two tests. Now let's run through the code here. So the first one was amending the existing test. Now, a few things that I have done differently, and some of these are because of the way that I'm running these. Now I have a suite of tests, so because this one, I need to make sure that it is in a specific circumstance where only one window is open to start with. I'm closing the browser down. I'm just quitting the driver before we start and then getting a new one on that page. Then this is much the same as the original test, where I get the current window handle. I switch to the content, click on the Selenium simplified link that will open up the new window. Then this is the part where I try and find the handle for the new window. And what I'm doing is I'm basically creating a string called new window handle, which I initially set to be the same value as the frames window handle. Then I iterate over the list of Windows handles from the get Windows handles command, and if I find one that is not the same as the frames window handle, then I assume it is the new window handle, and then we carry forward with that value. So then I switch to the new window. Now I had some issues running this stuff in a suite, so I have added a WebDriver wait until the title is what I want. That's an OK synchronization. Then clearly I don't need this additional assert because the wait would fail if this is not true. But essentially I'm switching to the window, asserting that I'm on the correct window. Then I switch back to the frames window, which should be open. There should be no synchronization problems. And then just get the title is correct. Then I have to tidy up after myself, which means I switch back to the new window and close it. And then I switch back to the frames window to make sure that there is one window open and it has the focus, and I'm ready to move on to any other exercises. Now the switch to by name, again I'm closing the driver down because these tests can run in any order, and I want to be in a specific set of circumstances when I run this test. I want a single window open. So I close the driver, then open up a new one with the correct page. And on this one we're switching to by name. So the first thing I have to do is go into the content frame, find the two links that will let me click. And I hope you spotted what it is that makes a difference on the anchor when it is going to open up in a new window. Let me just show you. So here, let's inspect this. So I hope you spotted what was different about these links. With the EvilTester.com, I've got an on-click event here. So this window has been opened with JavaScript, and there is the name there, Evil. So this JavaScript command to open opens on the link with a name. In this one here, there's no JavaScript involved, but the target is named. So this is saying when this window is opened, this is the name to give it. And the Selenium simplified one does not have a name. Or it does, but it's blank. This is the traditional way of putting in links, but we can name them. So these two have names. This one is named by JavaScript. This is straight HTML. This one has no name. So I have my elements and I've clicked on them. Then I can switch between the windows. The first thing is I switch to the window compDev because that is a named window. And then I assert that we've got the title correct. Then I switch to the window Evil. We know what the name is so we can switch to it directly. Then, using the window handle that we got up here, I can switch to the frames window and check the title. Then it's a simple matter of tidying up after myself, where I switch to the comp dev window and close it, and switch to the Evil window and close it. Now if anything goes wrong in these tests, I'm leaving some windows lying about, which is why it's very important that I do a driver quit on each one of these. However, if the test fails, and it's the last test in this particular class to fail, I may have left some browser windows open. So I may perhaps want to do a driver.quit in here, or an after class that quits the driver or closes any browsers down. This test doesn't clean up nicely after itself, should there be a failure. Clearly, I'm anticipating no failure, and that's how I've written this test. Now look at the API to manage the window. This is to manage the current window. So having switched to it, we can then manage it, and we're managing the window. There are other commands underneath manage. We're looking at manage window. So from the manage window, we can maximize it. We can get the size. We can set the size, get the current position, which is the XY position of the window, then set the position to move it around. So this is letting us control the size and the position of the window, or maximize it. Let me show you a quick example test for this. Now remember, this test is annotated. We'll have a look at the code in a minute. So in this particular example, I'm using the frames again. Don't have to, it could be anyone, but I'm just using the frames as an example. So you can see that long chain of commands, driver.manage.window.setPosition. Basically, I'm getting the current window through driver manage window, then setting the position. And position returns and takes a point. And the point is just an abstraction around the X and Y coordinates. So first of all, I set the position, which will move it from the 0, 0 down to 10, 20. So we should see the window shift. Then I get the current position, check that we've moved to the correct place. Then I change the dimensions of the window with set size, which takes a dimension object. Then we get the size and just double check that it has been set to the correct size that we wanted. And let's look at the code for this test. So we'll see it running first. This will probably go fairly quickly. We may do this test in debug mode as well. That was a bit fast, but you saw the window shifting about there a little bit. So let's drop down through this in debug mode. Let me put this here. So behind the IDE is the window. We are in debug mode. Let me close this. So line by line, the first thing we're going to do is set the position to 1020. Let's see what happens. So you see the window has shifted down there. Let me close this window at the back. Next thing I'm going to do is get the position and make sure it is 1020 as we set it, which it is. Then I'm going to set the size. So the window should shrink up at this point. And then what we're going to do is just assert that the size is correct. So let's have a look at this code in a bit more detail. So this chain is fairly horrible. Theoretically, I don't need to do this. What I can do is say, I'm going to call this Winnie. And it's a window. There is a WebDriver.window object. So let's import that. And we want the WebDriver one. There we go. I will choose how to do that, thank you. And then I can just say winnie.setPosition. So I don't need that big chain. I can put it in if I want to. And the reason I put it in is it just makes it clear for this initial example. Chances are normally we wouldn't do that. And this Winnie will be fine until we open up a new window or start messing things around. I just want you to be aware that that was a possibility. Let me just Control Z all this stuff. Then the next thing to be aware of is currently, and this may be a distraction, currently we're looking at the window part of management, but you can see that under management we can manage timeouts and cookies and various other things, but we're focusing on the window management at this point. This exercise should be a little fun. It will show your mastery of the window management functionality. So I have created a page called selenium/bounce.html, and you're going to use that page to do these exercises. First thing you're going to do is create a test to maximize the window. Then you're going to create another test that will reduce the window to half the size. Then you're going to create another test that will move a half-sized window into the center of the screen. And hopefully this one will prove more enjoyable. Make the window even smaller and then have it bounce around the screen. Okay, see if you can do that. The last one is a bit of fun. Don't spend a lot of time on it. This whole thing should be 15-20 minutes max. But if you can make it bounce around the screen, I think you will enjoy that. And when you come back, we'll have a look at my answers to this, and we'll see the screen bouncing around. So as is traditional, we will start by running the test. So now you can see why it was called arg. So that is now bouncing around the screen. Hopefully you made it bounce a little bit more and had some fun doing that. So let's have a quick look at these results. So to maximize the window, that's not hard because it's a single command to maximize the window. What's hard is asserting, have you got the size correct? So the way that I'm doing that is through the Java toolkit functionality to get the screen size. Then I've created a 90% tolerance on the screen dimensions against the browser window and gone, yeah, if the browser window is like 90% of this screen size, then it's okay. So that's what I'm asserting on. I don't know how you did it or whether you even went that far, but that's what I did. So to half size the window, that was fairly simple. All I did was maximize the window, get the size of the window, then set the size to half that size, and then just assert that that was correct. Moving it was equally easy. Same code basically to set the size, then all I do is set the position based on the size of the original window. Now bouncing the window, this isn't particularly good or nice code, so I'm not sure how you did it. The important thing from a Selenium point of view, clearly, is just the initial setting of the size, then continually changing the position. So bouncing it is done by set position, or moving it is done by set position. Now the way I bounce it is by, if the X and Y that I'm tracking over time actually moves off screen, then I change the iterator that I've got, because I will run through and I will add 10 to the X and 10 to the Y for each loop. But if we start going off the side, then I will start adding -10. Then I will switch back to 10 when we go off the other side. So that's all that happens. When I go off the bottom of the screen, we reverse the number to be negative or positive, or depending on where I want to bring it back. So I haven't ever really needed to use these management functionalities a lot in production. I think I've used it once when we had a field that went off the bottom of the screen, but then WebDriver got updated and we didn't need to do that anymore. So I don't think I've really used these functions in anger in production, and that's why I came up with this very jolly exercise for management.
And just for entertainment value, I'm going to increase the bounce iterations to 1,000. Not 10,000, that'd be way too much. Let's see how long 1,000 gives us. And this way, because the screen is full, you'll be able to see the whole thing in all its wonderful details. Let me just run this bounce the window test. Well, that always entertains me.